Algebra I 11.8 Pythagorean Theorem word problems. I have 3 of them for you. The Pythagorean Theorem can help us figure out distances that aren't easy to measure and also lets us test if a triangle is a right triangle. So the Pythagorean Theorem is a squared plus b squared equals c squared. That's a leg plus a leg is going to equal the hypotenuse or the long side. And if a triangle has measures of 1 inch, 2 inches, and 3 inches, is it a right triangle? Well, this will help us test it. So we do 1 squared plus 2 squared equals 3 squared. Well, 1 plus 4 is 5. That's not 9. So no, that would not be the measures of a right triangle. Now we talked about this in video 11.7a and 11.7b. And if you click on the description of this video, there'll be links to these 2 videos if you're confused about this, all right? That means you skipped into my playlist and missed some points, okay? So you could just watch those really quick and come back to this one, or watch this one and then go back to that one. So here we have a baseball field. We've got home plate, first base, second base, third base, and each of the bases are 60 feet apart. Now, because it's a perfect square, they're all going to be 60, aren't they? So if the distance between each base is 60 feet, what's the distance between second base and home plate? So it's a perfect square. All the sides are 60 feet. We can use the Pythagorean theorem, a squared plus b squared equals c squared, and we'll put 60 squared plus 60 squared equals c squared, that distance between second base and home plate. 60 times 60 is 3,600, so we do it again. 3,600 plus 3,600 is 7,200, 7,200. Well, that means c squared is equal to 7,200. We take off this little exponent of 2 and put the radical sign on the 7,200. We've talked about that before. We can interchange them. We could take this radical symbol off the 7,200 and put the little square 2 back on. So we need to find the square root of 7,200. Well, this is how you can think. If 6 times 6 is 36, and 60 times 60 is 3,600, then we're going to be dealing with something in the tens. That means 8 times 8 is 64, so 80 times 80 must be 6,400. See? So it's going to be between 80 and 90, because those are the perfect squares that 72 falls between, or 7,200 falls between. So we know it's between 80 and 90, so we do a little math, and we think about how far away 7,200 is from 6,200. That's about 800 away. And it's about 900 away from 8,100, so it's almost in the middle. So we try 85. That's between 80 and 90. And we get 7,225. And when we do 84, we only get 7,056. Well, that's too small. So we're going to use our approximate symbol and say it's about 85. See? 85 times 85 would get us close to that 7,200. See? All right. So now we have a 10-meter ladder leaning against a building, and the bottom of the ladder is 5 meters from the building. So how high is the top of the ladder? I mean, it wants us to round to the nearest tenth. So here's our building, and we don't know how high this is right here, B. We know this is 5 meters away from the building to the bottom of the ladder, and the ladder is 10 meters tall. So we use the Pythagorean theorem and we plug in what we know. So that's 5 squared plus b squared equals 10 squared. We can flip this around and say 10 squared minus 5 squared equals b squared. And 10 squared is 100, 5 squared is 25, so that must be 75. So b squared equals 75. We take off the little 2 exponent, put the radical sign on the 75. What's the square root of 75? Well, it's in between the square root of 64 and 81. But 75 is 11 away from 64. That's pretty far, and it's only 6 away from 81. So we know it's more than halfway. We know it's more than 8.5. It's in between 8 and 9, but it's more than half the way. So let's try 8.7. We do 8.7 times 8.7 and get 75.69. It wants us to round to the nearest tenth, so we get 75.69. 7. The 9 tells the 6 to round up to a 7. That's pretty close to 75. See? We use the approximate symbol because it's not exact. An isosceles triangle has two congruent sides of 6 centimeters. And it's got a base of 7 centimeters. So what's the height of the triangle? Well, think. The height divides the base in half to 3.5 centimeters and 3.5 centimeters. So if we draw this height line right here, that's splitting the base into two parts. And we don't need this part right here. All we need is this triangle, see? So we've got 3.5 and 6 centimeters, and now we're trying to find what B is, or H for height, okay? We didn't even need this side of the triangle, did we? All right, so we do 3.5 times 3.5, and we get 12.25. We need to add that to the height squared, and that's going to get us this 6 squared, 36. We can flip this around to find the height, which is the same as B, and in the Pythagorean theorem, and we get 36 minus 12.25 is going to equal that height squared. Well, 36 minus 12.25 is 23.75. So again, we do the same thing we did with the other problems. Height squared is going to equal 23.75. We remove this little 2 exponent, put the radical sign around that, and we try to figure out what this is close to. And the square root of 23.75 is in between what perfect squares? It's in between 16, which is 4 times 4, and 25, which is 5 times 5. So we know our answer is between a 4 and a 5. And it's closer to 5 because 23 is really close to 25. It's not that close to 16. So let's try 4.8 and 4.9 because we know it's going to be a decimal because it's in between 4 and 5. So it's like 4.5, 4 3/4. So 4.8 times 4.8 is 23.04, and 4.9 times 4.9 is 24.01. That's really close to 24. It's closer than this one, so we can say it's approximately, use the approximate symbol, 4.9. That's rounded to the nearest tenth. Even if it was 4.85, that 5 would make the 8 round up to a 9, and we'd still be at 4.9. See? So, just remember it cuts the base in half when you're doing the height, all right? Our next video, 11.9a, we're going to talk about equations with radicals. And if you want to see those previous videos about the Pythagorean Theorem, finding the legs and the hypotenuse, or even the distance formula, there'll be a link in this description so you can just click on them, okay? All right, and I'll even have a link to my algebra word problem playlist, and you might find other word problems in there that can help you, all right? So, hope this was helpful, and I'll see you next video. Keep your chin up. We're almost through with Algebra 1. Bye.